Dividing polynomials using long division. So do you remember back in elementary school when you first learned how to divide using long division? If we're dividing 512 by 5, you would take 512 and write it underneath that symbol, and then we would put a 5 on the outside to divide. So you would ask, how many times does 5 go into the first digit 5? We would say it goes in once, then multiply 1 times 5 to give us 5, and then we would subtract down, so this gives us 0, and then you bring down the next digit. So you ask yourself, now how many times does 5 go into 1? That would be 0. Then we multiply 0 times 5 to give us 0, and when you subtract, you would have 1, and you bring down the next digit 2, and then ask yourself how many times does 5 go into 12? It goes in 2 times, and then multiply 2 times 5 to give you 10, subtract, and this would be our remainder of 2. So your answer to 512 divided by 5 would be 102 with a remainder of 2. So today we're going to learn about how to divide polynomials. Here we want to take x cubed plus 2x squared minus 6x minus 9 and divide it by another polynomial, x minus 2. So let me show you what steps we're going to take to divide polynomials. First, we're going to set up our division problem the same way that we did our old long division with just numbers. You take the dividend, x cubed plus 2x squared minus 6x minus 9, and then we're going to draw our division symbol. Then we're going to take our divisor x minus 2 and place it outside. One key step in dividing polynomials is that if you are missing any terms in the dividend, you're going to have to substitute in a 0. That means if you're looking at your exponents, we have x cubed, x squared, x to the first, and a constant. So from our x cubed, we are not missing any exponents to get to the constant. So we don't have to substitute any. But if we were missing any, we would just put a 0 as a placeholder. So our next step is going to be to divide. So you're going to take your first term, our x cubed, and we want to divide it by x. X cubed divided by x is x squared. And then step number 3, we're going to multiply our x squared times our divisor. So x squared times x will give us x cubed. X squared times negative 2 is going to give us negative 2x squared. Then we need to draw our line and subtract down. Before we subtract down, we want to change our signs so that we make sure we subtract. X cubed minus x cubed cancels out to 0. 2x squared plus 2x squared gives us 4x squared. Next, we want to bring down the next term in our polynomial, so our minus 6x. Then we want to follow the steps we've just completed. So we're going to take our 4x squared and divide it by x, which is going to give us a positive 4x. Then let's multiply 4x times x gives us a positive 4x squared. 4x times negative 2 gives us negative 8x. And then we'll continue. We're going to subtract down. So again, change your signs and then subtract. 4x squared minus 4x squared cancels out. Negative 6x plus 8x gives you a positive 2x. And then bring down your next term, our minus 9. Then we're going to take 2x and divide it by x, which gives us a positive 2. And then let's multiply. 2 times x is 2x. 2 times negative 2 is negative 4. And then lastly, we need to subtract. So let's go ahead and change our signs. And then 2x minus 2x cancels out to 0. Negative 9 plus 4 gives us a remainder of negative 5. Now, when we did long division in elementary school, you would write a remainder of negative 5. That's not how we're going to write our final answer when we are dividing polynomials. The way we write our final answer is we're going to take x squared plus 4x plus 2, so that's everything we got here. Then you're going to take that remainder and we're going to put that at the end, minus 5, but you're going to put it over our divisor, x minus 2. So this is going to be our final answer. If you have a remainder, you're always going to put it at the end over your divisor. Let's walk through one more example together. In this one, we're going to address one of the rules that we didn't use in the previous problem. So from the highest exponent that you have in your dividend down to the constant, you need to place a 0 for any exponents that are missing. So here, if you notice, we have an x cubed is our highest. We're missing an x squared before we get to x to the first and then our constant. So if you make a note that we're missing our x squared term, when we go to write this underneath our division symbol, we're going to write x cubed, and then you're going to put a plus 0 for your x squared, and then minus 10x minus 24. Then we can go ahead and place our divisor, x plus 3, on the outside. It's really important that you do not forget about that 0 placeholder. So let's go ahead and continue. Our first step is to take our x cubed and divide it by x. When you divide those, you get x squared. So then we're going to multiply. X squared times x gives us x cubed. X squared times 3 gives us positive 3x squared. Then we want to subtract. So we're going to change the sign of the bottom one. Change that to subtraction. So x cubed minus x cubed is 0. 0x squared minus 3x squared is negative 3x squared. Then bring down your next term, negative 10x. And then you want to take your negative 3x squared and divide it by your x. So we're going to get negative 3x. Then we'll multiply. Negative 3x times x gives us negative 3x squared. Negative 3x times 3 is going to give us negative 9x. And then we need to subtract. So let's go ahead and change the signs. And then negative 3x squared plus 3x squared cancels to give us 0. Negative 10x plus 9x gives us negative 1x. And then we're going to bring down the next term, negative 24. And then let's go ahead and take our negative x divided by x. So that gives us a minus 1. Then minus 1 times x gives us a negative x. And a negative 1 times positive 3 gives us a negative 3. And so we're going to subtract one more time. So we change our signs to subtract. Negative x plus x cancels to give us 0. Negative 24 plus 3 is negative 21. And this is going to be our remainder. So again, in writing our final answer, we're going to take everything before our remainder, x squared minus 3x minus 1. And then our remainder, we're going to write minus 21 over our divisor, x plus 3. So I want you to pause, try example 2, and check back with me when you're finished. So if you worked out example number 2, hopefully you should have gotten that you have no remainder when you finish dividing your polynomials. And that's okay. Sometimes that's going to happen. So your final answer should be 2x squared plus x plus 3. If if you didn't get that answer, I want you to pause and check your work with mine and see where you might have made a mistake. Next, I'm going to show you how to use long division to factor polynomials. So we have a polynomial x cubed plus x squared minus 10x plus 8. And I've given you that one of the x's equals negative 4. So the first step is to take the given 0 and turn it into a factor. So if x is equal to negative 4, to turn that into a factor, we need to get one side equal to 0. So if we add 4 to the other side, we have x plus 4 is equal to 0. This is going to be our factor. So we're going to use x plus 4 to divide x cubed plus x squared minus 10x plus 8. Then let's walk through dividing our polynomial the way we just learned how. So x cubed divided by x is x squared. Now we want to multiply. So we get x cubed plus 4x squared. Then we're going to subtract. So this cancels. We have negative 3x squared. And we're going to break down our next term. Then we're going to divide negative 3x squared by x, which is negative 3x. And then when we multiply, we'll get negative 3x squared minus 12x. And then we want to subtract. So we're going to change our signs. This cancels. We get 2x, and then bring down our last term, positive 8. And then we want to divide 2x by x, which is a positive 2. And then when we multiply, we get 2x plus 8. And then, of course, when we subtract, everything will cancel, and we have a remainder of 0. So, after we complete our long division, to completely factor our original polynomial, step 3 says to take the quotient and factor it to find the remaining zeros of the function. So, we're going to take our quotient, x squared minus 3x plus 2, and we're going to factor this the way we know how. Find the multiples of positive 2, which is just 2 and 1, that add up to negative 3, so a negative 2 and negative 1. So we're going to get x minus 2 and x minus 1. And this is our fully factored form. These two that we found, and then our original factor, x plus 4. So here's our factored form. If we wanted to find all the zeros of the function, we already know that x plus 4 gives us x equals negative 4. We would set our other factors, x minus 2 and x minus 1 equal to 0, and solve. So we get x equals 2 and x equals positive 1. So here would be our 3 zeros of the function. So let's go ahead and walk through one more example together. So our first step is to take our given 0 and turn it into a factor. So this is going to be x minus 3 equals 0. And then we'll take that as our divisor, and then divide our original polynomial, x cubed plus 3x squared minus 34x plus 48. Then let's go ahead and walk through the process. We have x cubed divided by x is going to give us x squared, and then we're going to multiply x cubed minus 3x squared. And then let's subtract. This cancels, and we have 6x squared. Bring down the next term. And then let's go ahead and divide. 6x squared divided by x is a positive 6x. And then we'll multiply 6x squared minus 18x. So let's go ahead and subtract. So we change our signs. This cancels out, and we have negative 16x. Then bring down your next term, plus 48. And then we're going to take negative 16x divided by x, and we get negative 16. So then let's multiply negative 16x plus 48, and then we're going to subtract. So change your signs. This cancels, and we have 0. So that's the remainder we wanted. Now we're going to take our quotient, x squared plus 6x minus 16, and then factor it. So the factors of negative 16, we have 16 and 1, 4 and 4, 8 and 2. The ones that add up to positive 6 are positive 8 and negative 2. So we have x minus 2, x plus 8 to continue factoring. So our final factored answer is going to be x minus 3, x minus 2, and x plus 8. And again, if I was asking you to find the zeros of the function, you would just take each factor, set it equal to 0, and solve. Now I want you to pause, try the second example, and check back with me when you're finished. When you fully factor this polynomial, you should have gotten x minus 1, 2x plus 1, and our original factor that we were given, x plus 2. So in this one, after you complete long division, you should have gotten a remainder of 0. And then when you take the quotient, this one, because we do have a leading coefficient that's not equal to 1, you are going to need to factor this by grouping, and then you'll have 3 factors at the end. So again, if I asked you to find the zeros of the function, you would just take this one step further and take each of your factors, set them equal to 0, and solve for x. That's it for this lesson on long division of polynomials, and back